Hello everyone, so this is May-June 2011, paper 2-2, chemistry, A-level chemistry. So the question says, ethanoic acid can be reacted with alcohols to form esters, an equilibrium mixture being formed. And this is the reaction equation given to us. Now it says that the reaction is usually carried out in the presence of an acid catalyst. So write an expression for the equilibrium constant Kc for this reaction, clearly stating the units. So as we know, we have to write the products first in the numerator and the products in the reactants in the denominator. So this is what I've done over here as well. And since there are no coefficients with any of the reactants or the products, they are going to be written as is without any powers. And because there are two products and two reactants, the units will be squared in both the denominator and the numerator, and they will be cancelled out, so the Kc does not have any units in this particular question. Next, it says that in an experiment to determine the Kc, a student placed together in a conical flask 0.1 mole of ethanoic acid, 0.1 mole of an alcohol ROH, and 0.005 moles of hydrogen chloride catalyst. The flask was sealed and kept at 25 degrees Celsius for 7 days. After this time, the student titrated all of the contents of the flask with 2 mole dm cube NaOH using the phenolphthalein indicator. At the end point, 22.5 centimeter cube of NaOH had been used. So now we have to calculate the amount in moles of NaOH used in the titration. So we know that the formula is concentration is equal to moles over volume. So when we rearrange that formula, we get moles is equal to concentration into volume. So they've given us the concentration of NaOH, which is 2 mole per dm cube, and the volume we have is 22.5 centimeter cube. So we have to convert the centimeter cube to dm cube first, and then we will multiply it with the concentration to get the moles of NaOH. Okay, so now moving on to the second part, they say that what amount in moles of this NaOH reacted with the hydrochloric acid. So first, it's better that we make a balanced equation so that we can know how many moles of HCl are needed to react with how many moles of NaOH. So I've written out the equation first, and we can see that there's clearly a 1-to-1 ratio. So as many moles of HCl that we have, those are the same number of moles that are going to react with NaOH as well. That we need for NaOH as well. So they were originally told us that there are 0.05 moles of hydrochloric acid. So the 0.005 moles of NaOH will react with the HCl as well. So then in the third part, they've asked us to write a balanced equation for the reaction between ethanoic acid and NaOH. So this is a simple equation as well. It's a 1-to-1 ratio because the Na will just substitute the OH, the H, and then water will be formed. So this is a simple equation, we can write that. Then the next part is, hence calculate the amount in moles of NaOH that reacted with the ethanoic acid. So now we know that we originally had 0.045 moles of NaOH in our reaction, and 0.005 moles of that have already reacted with the hydrochloric acid at the end point. So now the remaining moles are 0.04 of NaOH that are all going to be used to react with the ethanoic acid, because the ethanoic acid is in excess. So all of those remaining moles of NaOH are then going to react with the ethanoic acid. Okay, so for our next part, it says that use your results from B to calculate the amount in moles of ethanoic acid present at equilibrium, hence complete the table below. So this part might be a little confusing, so which is why it's important that we do our proper working over here. So in the previous part, we could see that 0.04 moles are left of NaOH that are going to react with the ethanoic acid. So because NaOH and ethanoic acid have a 1-to-1 ratio as well, so 0.04 moles of ethanoic acid would react with the same number of moles of NaOH. Now we know that in the question originally they have told us that we have 0.1 moles of both the ethanoic acid and the alcohol. So our initial moles for both of them would be 0.1. And because 0.04 moles are needed to react with the NaOH, so the remaining moles of ethanoic acid are going to react with the alcohol. So now when we subtract 0.1 minus 0.04, we are left with 0.06 moles. So those are the moles that are going to react to form the product. Now because in the original reaction as well, we also have a 1-to-1 ratio. So both 0.06 moles are going to react for both ethanoic acid and the alcohol, and the same number of moles will be formed for the product as well. So for the equilibrium, we are going to use the reacted moles, which are going to be 0.06 over here, and not include the 0.04 moles that are reacting with the NaOH, because that is the end point. We are going to assume that the NaOH reaction has not been performed yet. That is just a reverse sort of, you can say, method that we use to calculate the moles that are going to react initially, because 0.04 moles that are going to be present at the equilibrium are then going to react with the NaOH later on at the end point. So we are going to calculate the equilibrium moles. So it's going to be 0.1, which are the initial moles for both ethanoic acid and alcohol, and minus the 0.06, which are the reacted moles, which leaves us with 0.04 moles of both ethanoic acid and the alcohol, and we are going to have 0.06 moles of both of these products formed. Now they've asked us to calculate a value for Kc for this reaction. Now we have the volume is going to be same for all of them, so we can just use because the reaction mixture is the same, so we are just going to use the mole value, equilibrium amount in moles that we have calculated in the previous part. So because we know that we created an expression in the first part actually, so the products are going to come first, and then new reactants are going to come in the denominator. So it's going to be 0.06 multiplied by 0.06 for the products, and 0.04 into 0.04 for the reactants. And when you put that into the calculator, that gives you 2.25. Okay, so for our next part, it says that esters are hydrolyzed by sodium hydroxide. During the titration, sodium hydroxide reacts with the ethanoic acid and the hydrogen chloride, but not with the ester. So suggest a reason for this. So a possible suggestion for this is that the activation energy required to react with the acid may be lower in comparison to the ester, so that the NaOH reacts with the acid more readily. This is a possible conclusion that we can deduce from this, because they haven't given us any sort of conditions that may be used during the reaction. They haven't mentioned that if there's heating used in the reaction, which is usually what is done when we hydrolyze esters. So that has not been mentioned in the reaction in the question at all. So this is something, this is a suggestion that we can give. That is the most sort of easy suggestion that we can come up with, given the information that they have already given us in the question. And we can just say that maybe the activation energy is higher for the reaction with esters, so it's lower with that of the acid, because it's going to be neutralization reaction, so the activation energy may be lower. So that makes a sense with the amount of information that they've given us in the question. And the next part is, what would be the effect, if any, on the amount of ester present if all of the water were removed from the flask and the flask kept for a further week at 25 degrees Celsius? Explain your answer. So we know that water is one of the products that we have in the reaction. So if the reaction is in equilibrium and some of the products is removed, the equilibrium is going to shift in a way so that more of the product is formed, so that we can readjust the equilibrium according to the Chatellier's principle. So if we remove some of the water, the equilibrium will shift to the right hand side, which is the product side, so that more of the ester can be formed and the equilibrium can be readjusted. So that is the answer to the last part. And yeah.